Hey everyone, welcome back. Today we're going to do a deep dive into the world of LLMs,
Yeah.
specifically how they can be used to generate structured outputs,
Like code,
like code,
SQL queries,
SQL queries,
even instructions for robots.
not just plain text,
Right.
but data that actually does something.
Absolutely.
It's pretty cool.
It's a rapidly growing area.
Okay.
We're seeing LLMs being used for increasingly complex applications, which means we need them to produce outputs
Right.
that other systems can actually use.
Okay, so how do we make that happen?
One common technique is called constrained decoding.
Constrained decoding.
Yeah, it's kind of like setting up boundaries for the LLM,
Right.
giving it specific rules to follow.
Got it.
So the output has the right structure.
So we're shaping the LLM's creativity a little.
Exactly.
But how do we actually define those rules?
One way is with context-free grammars, or CFGs.
CFGs, okay.
Think of it as a blueprint for the structure we want.
Whether it's code JSON data or even a set of commands.
So CFGs can define the rules of the language.
Precisely.
Got it. So a CFG is like a set of instructions
Yeah.
telling the LLM how to put the pieces together in the right order.
Yes.
But I've heard that traditional CFGs can be a bit slow.
They can be.
When we're talking about LLMs, why is that?
Well, the way traditional CFGs are interpreted
Okay.
is through something called a push-down automaton, or PDA.
A PDA.
Yeah, imagine it like a tiny virtual machine
Okay.
with a stack for keeping track of the structure.
Okay.
The PDA reads the CFG rules
Right.
and uses those to check if the tokens the LLM is generating are valid at each step.
So the LLM is proposing words or pieces of code, and the PDA is like a grammar checker, making sure everything fits the rules.
That's right.
Got it. But the problem is...
Well, the problem is that these PDAs have to look at every possible token
Okay.
in the LLM's vocabulary at each step.
Oh, wow.
And these vocabularies can be enormous, sometimes containing hundreds of thousands of words or even more.
So it's like trying to find a needle in a haystack.
Yes.
Checking every single word to see if it fits. No wonder it's inefficient.
It creates a ton of unnecessary checks,
Yeah.
especially since most of those tokens won't even be valid.
Right.
And that's where Xgrammar comes in.
Okay, Xgrammar.
It's a brand new type of grammar engine
Got it.
that's been designed to make CFGs lightning fast.
All right, so Xgrammar is like the express lane for CFGs.
You could say that.
Tell me more. What's the secret sauce?
The key innovation lies in how Xgrammar handles tokens.
Okay.
It divides them into two categories.
Okay.
Context independent
Mm-hmm.
and context dependent.
Okay, two types of tokens. What's the difference?
Think of the context independent tokens as the ones with clear-cut rules.
Okay.
Their validity can be determined
Right.
without needing to look at the big picture.
Okay.
Xgrammar cleverly pre-computes these and stores them in a special cache
Got it.
called the adaptive token mask cache.
So it's like having a cheat sheet for all the easy cases.
Exactly.
Smart. What about the context-dependent tokens?
Those are a bit trickier.
Okay.
They need the PDA to look at the entire structure
Right.
to determine if they're valid, which takes more time,
Mm-hmm.
but thankfully they're less common.
Okay, good.
But even here, Xgrammar has some clever tricks to speed things up.
I'm all ears. What kind of tricks are we talking about?
One of them is context expansion.
Context expansion.
Imagine you're generating a string within a JSON object.
Okay.
Most of the time, you can tell if a token is valid
Right.
just by looking at its immediate surroundings within this string.
Got it.
But there might be edge cases
Okay.
where you need to consider the entire JSON structure.
Right. Like if a specific character is only allowed within a certain part of the JSON object.
Exactly.
Yeah.
So Xgrammar anticipates these scenarios
Okay.
by pre-computing potential suffixes or endings
Got it.
for each rule in the CFG.
Okay.
If a context-dependent token doesn't match any of those pre-computed suffixes,
Right.
Xgrammar knows it's invalid right away
Okay.
without even fully checking it with the PDA.
So it's like eliminating impossible choices before they even become a problem?
Precisely.
That's brilliant.
It's all about efficiency.
But we're still dealing with PDAs and stacks.
Right?
Don't those things get pretty complex?
They can.
With all the branching possibilities?
They can, and that's why Xgrammar introduces another powerful concept,
Okay.
the persistent execution stack.
Persistent execution stack.
It's a special tree-like structure
Okay.
that allows Xgrammar to efficiently manage and branch multiple PDA stacks.
Wait, multiple stacks? Why would we need more than one?
Remember how CFGs can sometimes be ambiguous?
Right.
Meaning there could be several valid ways to interpret a given structure?
Yeah.
That ambiguity creates multiple possible paths for the PDA.
Right.
So we need multiple stacks to explore each of those paths.
So it's like having different grammar checking teams working in parallel.
Exactly.
Each looking at a different interpretation of the structure.
That's a great analogy. Okay. And the persistent execution stack makes it super fast to switch between these stacks or even create new ones as needed.
So it's flexible.
This is particularly helpful when you have tokens that share a common prefix.
Can you give me an example?
Sure. Imagine you have tokens like read, ready, and reading.
Okay.
They all start with read.
Right.
With a traditional PDA, you'd have to check the entire prefix for each token.
Yeah.
But Xgrammar's persistent stack lets it do these checks much more efficiently.
Got it.
It doesn't need to recheck the read part every single time.
That's clever. Avoiding those redundant checks must save a ton of time.
It does. And this ability to quickly roll back to previous states is also really valuable in other LLM applications.
Like what?
Think about editing or inserting new text. You often need to jump back and forth in the generation process.
Right.
Xgrammar handles these jumps smoothly.
So it's like a time machine for text generation.
You could say that.
You can rewind, fast forward, and explore different branches without getting slowed down by redundant checks.
Exactly. And this persistent execution stack is becoming even more important in advanced AI research.
Interesting.
Especially in areas like tree structure generation.
Okay.
Where the LLM's output isn't just a simple sequence of words.
Right.
But a more complex hierarchical structure.
Okay, this is all getting pretty futuristic.
It is an exciting time.
But before we get too far ahead,
sure,
I want to understand how this Xgrammar engine fits into the overall picture of LLM inference. It's not just some separate tool, right?
Right. Xgrammar is designed to be a seamless part of the LLM inference process.
Okay.
In fact, it overlaps its work on the CPU with what the LLM is doing on the GPU.
So while the LLM is busy crunching numbers on the GPU, to figure out the next word, Xgrammar is already working ahead on the CPU.
Yes.
Preparing the token mask based on the grammar.
That's right.
And right before the LLM needs to choose the next token, they sync up.
They do.
The GPU grabs that pre-made mask from the CPU.
Yes.
And uses it to ensure that only valid tokens are considered.
Precisely.
So it's like a perfectly coordinated dance.
I like that.
The LLM is figuring out what word to say next, and Xgrammar is making sure that word fits the grammar, all happening in perfect sync.
It's beautiful, isn't it?
It is, and because Xgrammar is so efficient, this synchronization adds almost no overhead to the process.
That's one of the best parts.
Wow. It's like getting structured output for free.
It's pretty close.
This is awesome.
It is, and it's not just theoretical.
Okay.
Xgrammar is being integrated into major open source LLM frameworks.
So this isn't just a research project.
No, it's not.
It's actually going to make a real-world impact.
It already is.
That's incredible.
Absolutely. Xgrammar is poised to pave the way for some really incredible LLM applications.
I'm excited to hear more.
But we're just getting started.
Okay.
There's a lot more to discover about Xgrammar.
Well, I'm definitely hooked. Let's take a deeper dive into how Xgrammar achieves these incredible speeds in part 2.
Welcome back. Let's unpack some of those technical details and see how Xgrammar achieves such incredible speed.
Right.
Remember how we talked about Xgrammar categorizing tokens as context-independent or context-dependent?
Yeah, and those context-independent tokens get pre-checked and stored in that adaptive token mask cache. It's like Xgrammar is doing a lot of the work up front.
Exactly.
So it doesn't have to repeat it later.
Right. And the adaptive part is really key here.
Okay.
It's not just a static cache.
So adaptive storage.
It actually changes how it stores the information.
Okay.
Depending on the tokens it's handling at any given point.
So it's not just a simple lookup table.
Right. It's more sophisticated than that. For each point in the structure, Xgrammar looks at the context-independent tokens and figures out whether they are mostly accepted or mostly rejected at that point.
So it's like determining the general trend. Are most tokens allowed here, or are most of them forbidden?
Precisely based on that trend. It picks the most efficient way to store the information if most tokens are valid, what they call an accept-heavy case.
Okay.
It just stores a list of the rejected ones, like a banned words list.
That makes sense. Why store a huge list of allowed tokens when you can just list the few that aren't allowed?
Right.
Kind of like packing for a trip. Sometimes it's easier to pack the things you're not taking.
Exactly. It's all about making the most of the memory
Right.
and making lookups as fast as possible. Now, if most tokens are rejected, a reject-heavy case,
Okay.
it does the opposite
Got it.
and just stores the few that are accepted.
So no matter the situation, Xgrammar is finding the most compact way to store those pre-computed token checks.
Yes, very efficient.
But what happens when we hit one of those context-dependent tokens that can't be pre-checked?
That's where those PDA optimizations we mentioned earlier come in.
Right.
Along with the power of the persistent execution stack,
Okay.
traditional PDAs can sometimes get bogged down. With unnecessary branching and complexity, Xgrammar has a few tricks to streamline this process.
Okay. I'm ready for some PDA magic. Lay those optimizations on me.
One technique is called rule inlining. It's all about finding those small, fragmented rules in the CFG
Okay.
and merging them into their parent rules. Think of it like simplifying a complex sentence
Okay.
by combining short phrases into longer, more concise ones.
Got it. So it's like streamlining the grammar itself,
Exactly.
making it less likely to create those confusing branches and splits in the PDA.
That's right. And this rule inlining can actually make context expansion even more effective.
Interesting.
It's like having a wider view of the surrounding context,
Okay.
so you can rule out more invalid tokens.
Interesting. The more context you have, the more likely you are to spot a token that doesn't belong. Are there any other PDA optimizations?
Yes, Xgrammar also uses a technique called node merging. It analyzes the structure of the PDA
Okay.
and merges nodes that would otherwise cause unnecessary splits.
So it's not just simplifying the grammar. It's also optimizing the structure of the PDA itself.
Precisely. And all these optimizations work together
Okay.
to make checking those context-dependent tokens much faster.
Yeah.
But the real magic happens
Okay.
when we combine this with Xgrammar's ability to overlap its calculations with what the LLM is doing.
You mean that synchronization between the CPU and the GPU you mentioned before?
Exactly. While the LLM is busy on the GPU generating probabilities for the next token,
Okay.
Xgrammar is already working ahead on the CPU building the token mask based on the grammar. And right before the LLM needs to choose the next token, they sync up the GPU, grabs the pre-made mask from the CPU,
Right.
and uses it to ensure that only valid tokens are considered.
So it's like a perfectly coordinated dance.
I like that analogy.
The LLM is figuring out what word to say next, and Xgrammar is making sure that word fits the grammar, all happening in perfect sync.
That's a great way to put it. And because Xgrammar is so efficient,
Right.
this synchronization adds almost no overhead to the process.
Amazing. It seems like Xgrammar really is a game changer for anyone working with LLMs and structured data.
It is a very powerful tool.
But I'm curious, how does all this theory translate into real-world performance? Have they actually measured
They have.
how much faster Xgrammar is compared to other methods?
Yes, they compared Xgrammar to several existing grammar engines,
Okay.
including some popular ones like Outlines and the engine built into llama.cpp, using various grammars and tasks.
And what were the results? How much faster are we talking?
In some cases, they found that Xgrammar achieved up to a 100x speedup
Whoa.
in per-token processing for CFGs and for end-to-end LLM serving. They saw speedups of up to 80x.
Wow, those are impressive numbers. It's not just a slight improvement. It's a
Yeah.
complete change in how fast we can generate structured outputs.
Think about being able to generate structured outputs in real time
Yeah.
without any noticeable delay.
That opens up all sorts of possibilities.
It does.
For things like interactive AI systems, robotics, and so much more. This is really exciting. But is Xgrammar only for people with powerful GPUs and expensive hardware?
That's a good question.
What about folks working with more modest setups, or even on devices like smartphones?
Well, that's one of the things that makes Xgrammar so remarkable. It's not just fast, it's also incredibly portable.
Okay.
They've actually compiled it to WebAssembly,
Okay.
which means it can run right in your web browser,
Wait, in the browser?
even on a phone.
You're telling me I could have an AI agent on my phone
You could.
that's generating structured outputs all powered by Xgrammar?
Exactly. They've even integrated it with WebLLM,
Okay.
which is an LLM inference framework that runs in the browser. And the results are pretty amazing.
Wow.
They tested it on a MacBook and an iPhone,
Uh-huh.
and Xgrammar added virtually no overhead to the generation process.
That's mind-blowing. Xgrammar is making this powerful technology accessible to everyone,
It is.
not just those with high-end hardware.
It's democratizing access to structured generation,
Yeah.
allowing developers to build innovative AI applications that can run on a wide range of devices.
This is truly transformative. Xgrammar is fast, flexible, and portable.
It is quite a tool.
It's a triple threat. But I want to shift gears a bit now and talk about the bigger picture. What does Xgrammar mean for the future of AI?
Yeah.
And how could it change things as we know them? Let's explore that in part 3. Okay, so we've talked about how Xgrammar works, its impressive speed, and how portable it is, but now I want to kind of step back and look at the big picture.
Okay.
What does Xgrammar mean for the future of AI? Could it really change the world?
Oh, it's a great question.
Yeah.
Xgrammar isn't just a technical advancement.
Right.
It could be the spark for a whole new wave of AI applications that weren't even possible before.
So what might this future look like? Give me some examples.
Well, one area with huge potential is human-computer interaction.
Okay.
Imagine AI assistants that can truly understand what you mean
Right.
and generate complex structured outputs that go way beyond simple text.
So instead of just asking my AI assistant to set a reminder,
Right.
I could have it help me write code,
Absolutely.
compose music, or even control robots all through natural language.
Exactly. And because Xgrammar makes sure the output is structured correctly,
Right.
those interactions would be much more reliable and efficient than anything we have today.
It's like taking the power of LLMs and connecting it directly to the tools and systems we use every day. What about other areas? How might Xgrammar impact things like robotics or education
Yeah.
or even the creative arts?
Let's start with robotics.
Okay.
Xgrammar could be a game changer for building robots
Okay.
that can understand and carry out complex instructions in real time, even in environments
Right.
that are unpredictable and constantly changing.
So instead of having to pre-program robots for every specific task,
Exactly.
we could have them learn and adapt as they go, responding to our instructions with much more flexibility.
That's right. And think about what that could mean for manufacturing logistics. Healthcare, even exploration robots equipped with Xgrammar could handle tasks that are too dangerous or difficult for humans, all while being guided by our expertise.
It's like we'd be extending our capabilities,
Yeah.
reaching into new frontiers with the help of robots. What about education?
Education, definitely. Xgrammar could make personalized learning a reality,
Okay.
creating experiences tailored to each student's unique needs and learning style. Imagine AI tutors
Wow.
that can generate custom lessons, give feedback on assignments, and even adjust the curriculum
Okay.
based on a student's progress, all in real time.
It would be like having a personal tutor available to every student anytime they need it.
It could revolutionize education.
Yeah, it could completely change how we learn and teach.
Absolutely.
What about the creative arts?
The creative art, oh yeah.
Yeah.
Xgrammar could give artists and musicians powerful new tools for expression, allowing them to experiment with different styles and techniques,
Yeah.
guided by their own creative vision.
So AI could become a partner in the creative process,
Exactly.
helping artists explore new possibilities and push the boundaries of their art.
I think that's what's so exciting about Xgrammar. It's not about replacing human creativity
Right.
or ingenuity.
Yeah.
It's about amplifying it, giving us new tools
Yeah.
to express ourselves and solve problems in ways we never imagined.
This has been an incredible deep dive.
It has.
It feels like we've only scratched the surface of what Xgrammar is capable of.
We have. There's so much more to explore.
It's a truly groundbreaking technology that could reshape our world in amazing ways.
I completely agree. It's an exciting time to be involved in AI,
Yeah.
and I can't wait to see what the future holds.
And to all of you listening, thanks for joining us on this journey into the world of Xgrammar.
Yes, thank you.
We hope you've enjoyed learning about this amazing technology and are as excited as we are about its potential. What could you do with an AI that understands structure?
Think about it.
Keep exploring, keep learning, and keep diving deep.